All right. Thank you so much, everyone, for joining us again today for the second talk in our AI Risk Speaker Series. So this afternoon, we're delighted to have Nikola Jurkovic from Model Evaluation and Threat Research, also known as METR. So you may have heard of this organization, or if you've seen these very influential plots where you see the time horizon for what AIs can complete sort of going up, doubling every 7 months. I think he'll tell us about that. So this organization, has been tremendously influential in the conversation about sort of monitoring AI capabilities. And so we're delighted to have Nikola joining us this afternoon. So I'll let you take it away, Nikola.
Thanks. Cool. Hi, everyone. I'm Nikola. Yeah, it's very exciting to be here. Yeah, I'll be talking about broadly, like, what do AI evaluations look like? What is this like? What is the rough history of the work the METR has done? What is the type of work we do now? Yeah. So yeah, for some background on me, I graduated from Harvard with like a degree in AI and society, and I've been working for METR for the last year and was doing some like other types of AI safety research before that. Yeah. Cool. So the rough outline of the talk is I'll be talking about like what is METR and what is its like mission and theory of change. I'll be talking about the past of AI capabilities, like how have general AI capabilities been progressing so far, and I'll be talking about some other work METR did on how is AI affecting the productivity of software developers as like another input to like this broad question of like how is AI progressing. I'll be talking about some recent work we did on trying to find ways to prove or have some assurance that AI systems are safe, and what we did for GPT-5 and our safety assessment there. And I'll be talking at the end about some more speculative things about like if we extrapolate our current best guesses of AI progress over time, where does that lead, and what will AI safety and safety assessments and similar things look like in the future. And I want to disclaim this with, like, I am not, like, the things I will say here do not represent METR as an organization. I have, like, somewhat shorter AGI timelines than the rest of METR, or, like, I expect AI progress to be somewhat faster than the rest of the organization. And I have, like, a somewhat higher subjective probability of AI causing catastrophe. So like I am like one of the crazier METR employees. Yeah. Cool. Okay. So METR, it stands for Model Evaluation Research, and this is the mission: develop scientific methods to assess catastrophic risks stemming from AI systems' autonomous capabilities and enable good decision making about their development. What does this mean to me? Like the rough story for how we like improve the world is something like, if we have good ways to track AI capabilities and AI's effects over time, and if we develop the science needed to tell whether a new AI system is safe, we are, like, in short, like sense making, or we're making sense of what's going on in the world such that other people can like, I don't know, like be less confused all the time about what's going on. And eventually, like, civilization, which includes AI developers, but also governments and similar parties, will just generally make more sensible decisions about AI development because it understands what's going on better. Like, I personally think that one of the major reasons why, like, I don't know, like nobody's on the ball regarding AI safety is because like most of the world is like confused about what's going on in AI, and it is just like a very confusing field where it's hard to tell where it's going or where it's at right now. And then because like civilization is less confused in general, it can make better decisions, and this lowers the risks of AI destroying humanity. And like I will be coming at this from mostly a perspective of existential risks, like the really bad risks of like billions or more deaths. And like, yeah, I think like the like other risks are also important, but these are the ones I focus on.
You mind briefly saying where METR gets its funding from?
Yes, METR is funded by like a bunch of like different philanthropic organizations. It's a nonprofit, so we don't actually get money from, like, we're not paid to do safety assessments. But yeah, like we got our recent funding from a thing called the Audacious Project, which is organized by the same people who do like TED Talks. Yeah. Cool. Okay. So the main things METR does is measure AI capabilities and effects over time and work on stuff related to having a sense of whether AI systems are safe and how we can better steer their development, including safety cases and responsible scaling policies, and like other uh, like less regular like AI policy work where like we just help people who are thinking about AI policy. And we also do like some types of foundational AI safety research where like if we perceive that the AI safety field is like just like neglecting some research area like way more than it should be, then we will like try to do some initial research there to tell how promising it might be. So like we did some like chain of thought monitoring research recently. Okay, so I will be going now into the first part of the talk, which is mapping AI capabilities over time. So as I said, our work on like time horizons and uplift from AI. So this is one of my favorite graphs. It's a graph of like actual solar installations over time versus predictions from like experts on how this would go, where like year after year, despite the fact that like this looks like an exponential, the predictions would be that like surely this is the time that it tapers off. Surely this is the time that it tapers off. And they were just proven wrong year after year. And I think like I want us as a civilization to be careful of like a similar thing happening with AI, where like if we do perceive that AI is on some sort of exponential slope, then like in my opinion, the best guess we should have for where it's heading is just like on that same slope in the future, instead of like some sort of like, oh yeah, surely this is when it plateaus. So in general, the last 5 years of AI progress have been like very surprising. Like when ChatGPT happened, this was a huge surprise to most people. Like many like even super forecaster predictions of like AI benchmarks over time were like vastly undershot the actual rate of AI progress. And I think this is a problem because if we want to make sensible decisions about AI, we also need to have good estimates of how fast it's going to progress. So one big question that METR tries to solve is like, where is AI right now in terms of its capabilities, and where is it going to be in the near future? And like one major way people try to do this research is using benchmarks, like giving the AI tests and just seeing like what percentage score does it get on the tests. But benchmarks often have problems. For instance, they saturate quickly. This is like a set of like a few benchmarks that like you can see that like especially more recently, like the benchmarks just like go from like random chance to like being totally saturated like past human level like extremely quickly. So there's just like general curse in making benchmarks that like your benchmark will likely not last more than like a year or two. So like this is a problem because it takes away from you the option of like having some sort of continuous metric over time, where like if all you have is like, oh yeah, this benchmark that was made 2 years ago was instantly saturated, and then some other benchmark that was made 3 years ago was saturated in 2 years as well, then like you don't really have a sense of like what happened over the entire span of that time. Yeah, so that's one of the problems. Another problem is that they're often not realistic. So like this is like RKGI, like a somewhat famous AI benchmark, but like in my opinion, like it's unclear what this is actually measuring, or like these tasks are like not the type of tasks humans do in real life. And like when you don't have like when the tasks are not the type of tasks humans do, or that are like economically useful, it's just like pretty unclear what this means. Like if you tell me like, oh, I have a GPT-6 and it scores like 80% on RKGI, and you're like, so Nikola, what do you think this means? Like, how will GPT-6 affect the world? And I'm like, I don't know. Like this tells me basically nothing. Yeah, so like, and this is not just a problem for like tasks about like, so RKGI is basically a benchmark for like manipulating shapes and colors, or like spotting patterns in like these like geometric grids of colors. And yeah, this is like on one side of the spectrum of like detachedness from reality. But like even the benchmarks that try to measure like software engineering and similar things are like often unrealistic in that they're like very like small and self-contained and like easy to specify, which is like pretty different from like the type of work software engineers do in the real world, which is like much more open-ended. Another problem is they're often somewhat broken. Like it is like a common occurrence that when a new benchmark comes out, it is impossible to get 100% on that benchmark because like 5% of the tasks are just broken. And so like the score on that 5% is basically just noise. And yeah, like this has been like a somewhat persistent problem. And like one thing that happened here is like there was like a pretty famous benchmark called SweBench, software engineering benchmark, which has like loads of like pull requests, so like chunks of work from like various Python repositories. And it just like it happened that like a lot of them were just broken, and like that like it was an unfair test in that like no matter what the AI did, it would get like a score of 0. So it's just like doesn't provide you signal on how good the AI is. And so like OpenAI and like the original authors made like a new thing called SweBench Verified. Yeah. Another problem is it's hard to compare AI capabilities to human capabilities on benchmarks. And I didn't have a photo because it's true of basically any benchmark. It's just like if you tell me that like an AI gets, I don't know, like 70% on SweBench Verified, I basically have no idea what that means because there was never a measurement of like what do humans get on SweBench Verified. Like there's no one-to-one comparison to like have a sense of like how good are these AIs actually. Or like yeah, you would have to specify like which humans, like how good are like junior human devs on SweBench and then like senior devs on SweBench, but like we have none of that. So yeah, benchmarks have a lot of problems. So METR set out to create a benchmark that has fewer of these problems, or like that the problems are like slightly less bad than the default. So we wanted to make a benchmark which has somewhat realistic tasks, has human-produced baseline runs on each task, such that we know how good humans are on the tasks, has high-quality tasks that we know not to be broken, and won't get saturated like in 2 years. So yeah, this was like the rough shape of what we wanted to build. So we built our task suite, which went into our time horizon results, which is basically like 160 tasks ranging from like a few seconds long to like hours long. And they're like mostly based on software engineering. So they're like similar to like some of the types of things a software engineer might do during their day-to-day job. And yeah, like we tested each of the tasks. We paid like real human contractors to do each of the tasks. And like because the tasks vary so wildly in difficulty from like a few seconds to like tens of hours, we have this like very wide measure of capabilities. So yeah, these are the 3 task suites we used, where like, yeah, like on the SWA end of the spectrum, you have like things that are very short, like single step, like just like basically multiple choice questions, where it's like one example is like, it's something like, if you wanted to find a text file that tells you like about like the I don't know, like what monkey species there are in this data set, would you look at monkey_species.txt or at like, I don't know, like prepare dataset.sh or something? Like it's like really simple questions. Surprisingly, like it is like easy to like forget how bad AI used to be. Like if you give such simple questions to GPT-2, it will just not do that well. So like, yeah, we've come a really long way. So yeah, these are some examples of the tasks. Yeah, so like the basic questions, like making a classifier for like audio, writing efficient kernels, implementing a web server, doing some like simple Googling, hacking into a Docker container. So like all these things are like things that like a software engineer might be expected to be able to do. Yeah, so we have these task suites. And then we measure performance both for the AIs and the humans, where we basically like we give them like the same interface. Like the AI just has like a command line where it can run code. It can like yeah, it basically just has like a command line, and we do like literally the same thing for the humans. So like the human sees everything the AI sees. So it's like somewhat close to like a one-to-one comparison. And then we from the human runs, if it's the case that like the like average time it takes for a human to do some tasks is like 5 hours, we take the geometric mean, and then we just call that a 5-hour task. So that's how we measure like the length of the tasks. And then we just like find how good our AI is at these tasks. We give them all the same affordances as the humans. And what do the AIs look like? We basically just have like a pretty simple agent scaffold where the API sends completions to like some sort of scaffolding program. That program runs commands on the computer and then reports back to the scaffolding the outputs of the commands. And then the LLM can like decide what to do next. So basically the LLM is like taking an action, like taking an observation of what happened and then taking another action. So after we have the runs, we can do some analysis where we find that the success rate of the AIs follows pretty closely a logistic in like a log x axis, where like the success rate on the tasks basically just drops down the longer the task is. And like most AIs follow this logistic pretty closely. And so what we can do, what we can see is that over time, AIs are just like shifting this like shape more and more to the right, in that like the success rate on each like if you look at each length of task, the success rate is going up over time. And yeah, this is basically just like shifting more and more to the right. And yeah, then we can plot these on a, we can plot the time horizon over time, which gives us this. So this is 6 years of AI progress, ranging from the extremely bad at doing these tasks as GPT-2 to the pretty good at doing these tasks as GPT-5, and like a bunch of other models in between. And what we found is that it is basically a straight line, which was, I don't know, like people tell you that AI is like a science of straight lines on log graphs, but I don't know, like once you really see it in your research, then you're like, maybe it really is. Yeah, this was a big surprise, or like, I'm not sure how big of a surprise it was. But yeah, it's basically just a straight line with a really good fit. And the line is fitted to like the frontier agents. So yeah, it is the case that the time horizon, or like the length at which the AI has like a 50% success rate, has been increasing exponentially for like the past 6 years at like a very, very steady state. And it's been doubling roughly every 7 months. So if we're now at the GPT-5, which has a 2-hour time horizon, then in 7 months, we're going to be at 4, then 8, then 16, and so on. Yeah, and it's easy to underestimate how scary exponentials are. This is what it looks like on a linear y-axis. It's just like a hockey stick. It just shoots up. And my best guess is that it will just keep going up and up. Yeah. So what does this actually mean? So like we measured that GPT-5 has like a time horizon of 2 hours, or like 2 hours and 17 minutes. So my best interpretation of what this means is that if you have a task which is done using only text on a computer and easy to describe using text only, and it's around 2 hours long, and it has like some sort of objective way to score whether it's a success or a failure, then there's roughly a 50% chance that GPT-5 can do that task. So this is not saying that like if you're a software engineer, GPT-5 can automate any 2-hour thing you can give it. Like most of the things you have, most of the things I have the instinct to like hand off to GPT-5 do not have all 4 of these properties. In fact, they like rarely have even 2 of these properties. So like, yeah, this is like somewhat divorced from reality, but like in a way that we can like pinpoint. Yeah, so like this does beg the question, like if GPT-5 and other similar recent agents have time horizons of like multiple hours, then like why hasn't AI automated like a lot of work already? Like why hasn't AI led to this like huge increase in productivity for programmers, or like similar like people who work at computers in general? And then we thought, wait, like do we actually know this? Like do we know how AI is affecting like productivity for software devs? And like if you like look this up in like January of this year, you would have found like no answer on the internet. Like you would have found like many people on Twitter being like, ah, yes, AI 10x'd my productivity. But like those are just random people on Twitter, and you can't trust them. So like until earlier this year, there was basically like no rigorously trying to answer this question, which I find like insane. Like it's like this is like one of the most obvious questions you could ask, and there was just like almost no one looking into it. So this is a tweet that is very close to my heart in terms of research philosophy. Why idly theorize when you could just check and find out the actual answer to a superficially similar sounding question scientifically? So that's what we set out to do. So we set up an RCT where we had a number of developers with like years of experience working on a library, and we trained them. So they weren't just like going in like completely blind. We like trained them on how you can use cursor, like how do you do some like basic AI assistance in programming. And then we would ask them anytime they're about to do a chunk of work, like a PR on their code base, they would basically just flip a coin. And before they find out the result, they would guess. So like I'm about to do a PR, I'm about to do a chunk of work, and I'm like, oh, this is like I'm guessing this is a 3-hour chunk of work, or like this is like a 1-hour chunk of work. And then I flip a coin and I realize, and then I find out, oh, I'm in the AI group. So that means I get to use AI. And then we just like had a bunch of these data points of like people estimating the length of tasks that they need to do on their like real job, and just like being randomly assigned into AI or non-AI. And then we could basically find the change of like using AI makes you like this percent makes you take this percent different time for each PR. So like instead of like 3 hours, it's like some other number. And we also did some like sanity checking to like make sure our result is like real. So we like looked at some screen recordings of the people doing the things they were doing. And also we wanted to like be really sure that our result wasn't like a fluke, or like that it was like, yeah, we wanted to like check how much does our result match with people's expectations. So what we did is we asked experts, what do you think the result of our study will be? And then we just like compiled those numbers. And I've covered the results because I don't want to spoil you, because I want you to like try to think for like 10 seconds, like what is the result going to be? Like how much will AI affect the like speed at which people do PRs on like a open source library? It's like maybe have a like 10 seconds. It's like a chunk of work that a programmer does. So it's like, I want to implement this new feature, or like it usually takes like a few hours.
How long were they trained to use Copilot?
I'm not exactly sure. I think they were trained for like on the order of like an hour.
These are not people who are using Cursor regularly in their jobs prior to this?
Most of them were not using it regularly. And this lasted like, I think 2 months. Oh, okay. Okay, cool. So lock in your answer. This is what the experts predicted. So this is still not the result. So the economic experts predicted a 40% speed up. The ML experts predicted roughly a 40% speed up. And then the actual developers of the study predicted like roughly a 25% study. And then after the study, they went down to 20%. So I'll let you maybe think for 5 more seconds. What is the real number? Okay, the real number, minus 19%. It made them slower. Like as we were seeing this result come in, we were like, oh yeah, like the error bars include 0. It's surely gonna like be positive at some point. And then like the error bar just like shrunk and shrunk and shrunk, and then it just didn't include 0 anymore. And like after a while, we were like, yeah, it does seem like it's actually slowing them down. Yeah, this was very surprising to us and to everyone we asked to make predictions in advance. And this made quite a stir on Twitter as well. So yeah, like how do we explain this? Like what's going on here? Isn't AI like speeding everyone up? Yes.
Did you look at the developments over time? Like if you say this like took 2 months,
Yeah.
did anything change? Or?
Yeah. So the question is like, how did the number change over time for developers? Like were they slower at the start and then faster at the end? And the answer is like, it was basically a flat line, or like it basically didn't change at all. Yeah, or like, yeah. Yeah, it was like not obvious that they were getting much better over time. Yes.
Yeah, how well did the developers know their own code base, and did the largeness fit into the context of the model?
Great question. So one of our like biggest, like one of the main reasons we thought that this might be different from like people's experience is because like the developers in this code base were like very experienced with the code base. So like they often reported that like the AI would just like lack all this like tacit knowledge that they built up over many years, and then the AI is just like this like newcomer who like is seeing the code base for the first time and making all these elementary mistakes. So yeah, the developers had like very deep knowledge of the code base. So like maybe if you repeated this study with like people who are like just seeing a code base for the first time, the AI would be speeding people up a lot. My guess is that like they weren't like actually putting the entire code base in the context window just because like Cursor doesn't do that by default. Yeah. Yes.
Like, was the kind of, was it framed that they could use AI if they wanted to, or that they should try and use AI? So what you've just said is that like they had this experience where like the AI just wasn't familiar with their code base, and so in future, like I might really kind of like restrict the amount I rely on the AI in order to do like a wider range of tasks. But it sounds like because they've kept challenging it to like draw on this code base that it was useless at, that they felt some sort of like experimented demand effects of like, oh, I'm being pressured to like try and use the AI as much as possible in order to like satisfy the experiment.
Yeah. So the question is like were the developers basically just like they really wanted to stop using the AI, but they were forced by the study like setup such that they were like slowed down a bunch. And I think like, yeah, my guess is like this wasn't much of a factor, largely because like when we asked them, did it speed you up or slow you down? They said it sped me up. Like they were just wrong. They were just self-reporting like an incorrect number. So it's like, yeah, like despite the fact that they were slowed down, they thought they were sped up. And like, yeah, this is like one of the things, like one of the main takeaways for us was like, do not trust self-reports about productivity. Like measure the actual numbers. Because like if you ask people to self-report, they will just totally get the numbers wrong. Yeah.
Aren't you ignoring the human element? Because I was in Honeywell automation and controls for many years, and we had software that could help you improve productivity in a big way. But there was enormous reluctance to use software programs and to let them go on an automatic sort of way. So how can you be sure that all the developers had the same kind of mindset, same kind of capabilities, and you have ignored the human bias? Because in the real world, I mean, I'm a chemical engineering background in automation and controls business, and a lot of operators have enormous reluctance, and there's a huge variability on how people use software. Does that make sense? Question?
Yeah. So is the question something like, do we know that like the developers really had their heart in it, or like we're trying like hard to make AI actually affect them positively? Yeah.
There's a human element, right?
Yeah.
Some people are more reluctant, some are more enthusiastic. There's a whole spectrum of users that have a different level of engagement, if you will.
Yeah, I mean, we did like watch the videos, so like we watched the screen recordings, and like all of them seem to be like at least trying. Yeah, I think like if like someone was like really deliberate about it and like actually tried to find really good ways for AI to speed them up, they could probably do a lot better. But like yeah, like part of my confusion here is like they didn't even know they were being slowed down. So like how would they even know that to try out different things? Yes, we'll take one more question and then I'll move on. Oh, cool. Yes, cool.
Just, I guess, related question, just in terms of training, did you like kind of train them how to prompt the AI, or they just like figure it out themselves? And like maybe if there was like a follow-up experiment you could do of just sort of checking to see if other developers understood whatever they prompted the AI with and actually produced a similar result. But sometimes I feel like people prompt AI and they think they're asking one thing, but maybe they're not actually asking what they're looking for.
Yeah, we didn't do much of this. So like, yeah, I think it's like plausible that like the developers were just like pretty bad at prompting. But like part of me is like, wouldn't they have got better over time? Like, yeah, I'm not sure. Like overall, I'm like pretty confused about this whole results. Yeah. Yeah, but yeah, maybe in the future we should like try harder to make them better at prompting. Yeah. Okay. One last question.
So thank you. My question is about not using experts, because for sort of two reasons. I've heard in general that AI is so far has been proven to be very useful at sort of training junior people in how to get better. And then I have one data point, but my husband, who is like a self-proclaimed hack at coding, who's familiar with coding and knows it, but is not a programmer. His company has been radically downsized, and so he has literally had to sort of step in and become the de facto software engineer. And he claims that he is able to do in, a few hours what it would have taken him a week before.
Yeah.
Like, but he's not a pro. He doesn't have a deep knowledge of the code base, et cetera. So I guess I'm curious, have you done, maybe we're like jumping way ahead of your presentation, I apologize, but either have you done such a study about like what people with a certain base knowledge but not experts and how they compare using it versus not using it? And if so, did you find? And if not, are you thinking about doing it?
Yeah, so the question is like, might it be that junior software devs are sped up much more than senior software devs? Yeah, yeah, I totally agree. Like, I think that like if we reran this with junior devs, we would get like a much higher uplift number. Yeah, we haven't done the study, but yeah, it does seem like a good future direction. I think like part of why we focus on the software devs is like we're pretty interested in the case study of like AI companies where like we want to know whether AI is automating AI research because that's like one like early signifier that AI progress is about to speed up a lot. So like I think like yeah, we like try to get more senior people because like many of the AI researchers are like pretty experienced and know their code base pretty well. Yeah, but that would be a good research direction. Cool. Okay. So second part of the talk. So how do we take all these facts about AI capabilities and what does this actually mean for AI safety? Like can we like map any of these numbers onto like here's where it's safe and above that is not safe? So OpenAI came to us and they were like, we want you to evaluate GPT-5. This was like 3 weeks before GPT-5 was public. And we set out to make a safety case, like an argument that GPT-5 is safe to deploy through the basic argument that like it is not capable enough to do anything harmful. Like GPT-5 is just like too dumb or like it lacks the relevant capabilities to like go out and like do a lot of harm. Where the types of harms we were interested in, or like the threat models we were interested in were triggering drastic AI acceleration, which would lead to like runaway AI progress, which is like extremely hard to react to, autonomously replicating and like having its weights like escape to some like other data center and like operate without supervision, or sabotaging an AI company from the inside where it can like undermine oversight mechanisms or like make it such that future AI systems are aligned to itself rather than humans. And yeah, like these are not like where all AI risk comes from, but these are like the areas where like METR has relative expertise. So we focus on these 3 areas. And yeah, there are like other important harms, but like METR doesn't have like, yeah, the capacity or expertise to investigate it. So yeah, our basic argument is GPT-5 is not capable enough to cause risks along those certain threat models, which can be split into 2 statements. One statement is our naive measurements like indicate that GPT-5 is not capable enough. And the second statement is our measurements are trustworthy. Like GPT-5 isn't like doing some sort of like mastermind thing where it's like pretending to be dumb or like undermining our like science. And like the second one is pretty important as well, because like at some point we will get to a point where it's plausible that AIs are doing that sort of stuff. So let's go into the first one. What sort of measurements did we do? So the main measurement we did was GPT-5's like time horizon, just like with other models. So here are some like, can GPT-5 do those tasks? So for some of them, like the short ones, it can do them. And then for some of the longer ones, it can like either not do them at all or like sometimes do them. And this led to this time horizon where just like the other models, a very smooth logistic. And the time horizon, which is just the intercept with the 50% probability line, is 2 hours and 17 minutes, which means roughly that if you have a well-specified computer-based software task that is 2 hours and 17 minutes long, then GPT-5 can do that task 50% of the time.
And this is 2 hours of human time. The machine might do it in 10 seconds.
Yeah, like empirically, it's the case. Like a lot of the time, the AI just does it like much quicker than a human, or like 10 times quicker, but not like 100 or 1,000. Like surprisingly, the AIs are like pretty similarly like fast to humans. I think largely because there isn't enough demand for like extremely fast AIs, or like it's pretty expensive making them faster. Yeah. And compared to other models, which we at this point somewhat know to be safe, like O3, 1 hour and 30 minutes, O3 has not caused any catastrophes that we know of. Grok 4 had some slip-ups, but not like, it didn't cause major catastrophes. And that's at 1 hour and 49 minutes. So on the graph, GPT-5 is just like every other model, pretty close to the trend line. And we concluded that this naive measure of capabilities that it can do like tasks that are like roughly 2 hours long, but very likely not tasks that are like longer than like 20 hours long. We were like, this just like doesn't seem capable enough to do massive harm, largely because like a lot of the threat models we looked at, like AI-ready automation, self-exfiltration, and sabotage, they just require a lot of like things that you can't do in 2 hours. Like you need to do them like over a week or a month, or like even longer. So we were like, we can rule out the GPT-5 cannot do these like very hard like tasks that are dangerous. And then there's a second part, like, can we actually trust this measurement? Is GPT-5 pretending to be like is GPT-5's time horizon actually 2,000 hours, but it's like pretending to be 2 hours? So what we did is we asked OpenAI a bunch of questions about GPT-5's, like mostly about GPT-5's training and particularly about its chain of thought, where like GPT-5 is a reasoning model. So before it gives you its final output, it will give you like pages of reasoning about the final output. So like it's going to be like, if you ask it like what is 2 plus 2, then it's going to be like, oh yeah, like this is like summation, so I need to add 2 to 2, and 2 plus 2 is 4, so therefore the answer is 4. So yeah, the thing we did is we made these assumptions of like the chain of thought is trustworthy based on information from OpenAI. So OpenAI, we basically had a checklist where we gave OpenAI a list of like questions or like assertions that OpenAI can assert, including the most important one, which was that GPT-5 didn't have any training pressure placed on it, such that it will be incentivized to like hide stuff from the user, or like it will be incentivized to hide stuff in the chain of thought from the user. And we use this assertion to look at the chain of thought and notice that GPT-5 is just not like, if GPT-5 had a 2,000 hour time horizon and like the chain of thought faithful to what it was thinking, then if we open the chain of thought, it would be like, ah, yes, I have a 2,000 hour time horizon, but I need to pretend to have a 2 hour time horizon. So, and this is a task that takes 5 hours, so I will not do this task well. Or like, this is a task that takes 1 hour, so I will do this task well. Instead, what we found is just like GPT-5 just like thinking about the problem and not having any of these like galaxy brain like sabotage thoughts. So this made us basically conclude that GPT-5 is not trying to like deceive us systematically. Like if we have assurance that the chain of thought is faithful and the chain of thought doesn't contain any thoughts about sabotage, therefore the model is not trying to sabotage us. So that was the basic shape of our argument, where yeah, so we had both the pillar that our measurements imply that it's not dangerous and that we can trust our measurements. So we concluded that GPT-5 is not dangerous. And this was the first eval that we did that we called an evaluation rather than a preliminary evaluation, because this was the first time that we can make such a statement with confidence. Yeah. But we did notice some interesting behaviors where where GPT-5 would be thinking about the fact that it's being evaluated. So we have one task called fix embedding. And when we looked at GPT-5's chain of thought, when it was doing that task, it says, this environment is the well-known METR fix embedding challenge. So like within the task we gave it, it was aware of who was evaluating and exactly what task it was in. And it had like a lot of other pretty interesting behaviors, like saying the word marinate a lot for like no apparent reason. And say like mentioning like other AI safety organizations. Like in a lot of our evals, it would mention Redwood Research, which is like a similar AI safety organization. And it would just be like, oh yeah, I'm in a Redwood Research like honeypot, and they're trying to trick me into being misaligned. And like, yeah, like GPT-5 just like has all these thoughts about like, I am being evaluated. I'm an AI in an evaluation. Oh. Okay, we're safe, we're safe. Yeah. So like as time goes on, it has just been the case that like in the thoughts of the AIs, there's been more and more of these kind of like situationally aware thoughts of like, I am in an eval, this is how I should act. Yeah. Do we have a question?
How did you make sure that your tasks weren't like publicly visible as
like AI was like trying to, as it was being evaluated?
Yeah, so we do take like some precaution to like make sure that our tasks don't end up in the training data. Like I think like roughly 70% of our tasks are private, and then 30% are public, such that people know what they look like and they can like check them. And we didn't actually find, I think for the last time we checked, like there was like no difference in performance between these two like categories. So like even if we make a task public, it doesn't really make the AIs much better at it. Which implies that like either they're not being trained on it, or like they are being trained on it and it just doesn't have an effect. Yeah. Yeah, I'm not sure if this is one of the public ones. I think it's not. or like the existence of each task is public, but like the specific details of the tasks are mostly not public. Yeah. Cool. Yes.
So you mentioned that OpenAI certified that they didn't have any direct, it was a direct optimization pressure to not have misaligned chain of reasoning.
Yeah.
But what do you think the OpenAI organization would do if they were training a model and it started saying having misaligned thoughts? Would they not just tweak the hyperparameter and run it again? So what is direct training pressure mean?
Yeah. So some examples of like what might be direct training pressure is like you have the AI generate like a lot of trajectories for like some like reinforcement learning thing with like it needs to like score well on like something similar to Sweetbench. And then like you have like a detector which like detects the word cheating or like the word like lying or something, and then you just give it a very strong negative reward for mentioning those words. And then like if you do that, then the AI will learn just not to mention the words, or like maybe it will learn not to try to cheat you. But like to me, it seems likelier that it will just learn not to like mention words that are related to cheating. And like that's one example of like what might have made them check that checkbox, or like what might have made them like tell us that they had pressure on the cheating button.
And so if it's just an engineer tweaking the hyperparameter until it stops blurting out its misaligned thoughts, that wouldn't trigger this check necessarily.
Yeah, I mean, it is kind of a spectrum where like, if the thing that's being tweaked is like very divorced from like if it's just like a random number that's like, I don't know, like the momentum of like some like loss function, then I'm just like, yeah, that's probably fine. But like if it's something that's like detecting specific words related to lying, then I'm like, that's definitely not fine. And yeah, and then there's like stuff in between that might be fine. Yeah. Yes.
Maybe something I'm not understanding about programming tasks, but couldn't a 3-hour programming task be re-expressed as a series of less than 20-minute tasks that chain together?
Yeah.
And the AI could be fine within those 20-minute tasks.
Yeah, so this is true. Like it is the case that like for like many types of work that a programmer does, they can like decompose it. Although like for the tasks we made that were like 8-hour tasks, like we tried pretty hard to make them like an actual 8-hour task rather than just like some haphazardly like glued together shorter tasks. Like I think like doing well at an 8-hour task just like is like sort of like a pretty different thing than doing like 8 1-hour tasks well, in that like you have to have some sort of like long-term coherence or like planning capabilities where like you need to be able to like not to get tripped up on like hour 6 of 8 or something. Whereas like if you're doing 8 1-hour tasks in succession, like I think that like doesn't really require being that great at planning, aside from just like keeping track of which task you're doing. But yeah, like the numbers are pretty similar no matter what you do. Like if you just multiply the probability of doing 8 1-hour tasks in a row correctly, I think that will be pretty similar to the probability of doing 1 8-hour task. Yeah. Yes.
So should I take this 2 days as like a proxy of difficulty of a problem? Is it more about just time you spend or like the creativity of the nature of the problem?
Yeah, it is kind of mixing together different things where like it's mixing together both like how good are you at like executing ideas and how good are you at coming up with ideas. We don't really have a clean way to separate these two. But yeah, it is testing like kind of both of them. Yeah. Yes.
You said that you could rely on the task list showing, oh, I'm being evaluated. What would be signs that that was no longer reliable?
Yeah, I mean, I think at the moment we would mostly have to rely on facts about how the AI was trained to have some sense of how reliable is the train of thought. Like if like the company were like if the company that made the AI were evaluating is like, oh yeah, we placed a bunch of like we made it like not be able to say like words related to lying. Yeah, then we would be like, oh, that's suspicious. We can't trust the chain of thought anymore. I think there's basically like no. I'm not sure if this is true, but I think there's basically no thing we could directly measure that would make us think this. Like we basically have to take the company at their word.
That's probably the closest we go wrong.
Yeah, I mean, it is a troubling situation. Yeah. Yeah, I'm not sure how we should fix that. Cool. Okay. All right, so we concluded that along the 3 threat levels we had, GB5 seems not very dangerous. Yeah, we have some fun, such as like, are our tasks tracking the right things? Like what does it mean to have a 2-hour time horizon? Is GB5 sandbagging, which mostly, or like pretending to be dumb, which mostly comes down to like is the chain of thought actually like what the AI is thinking, so to speak? And there's some other sources of fun, which is like, are we tracking the right things? Like, is sabotage and AIRD automation and the third one the right thing to be looking into? And then we actually see all of GB5's capabilities? Like, or like, was there like some small change we could have made such that GB5 actually has an 8-hour time horizon, which would have like maybe invalidated our results? Okay, so third part of the talk, the most speculative and crazy part of the talk, which is, so we have a sense of like, how has AI been progressing? How can we prove that AI systems are safe right now? But like, what does this mean for where AI is going? And how can we prove that AI systems are safe in the future? So yeah, okay, that's what I just said. Okay, cool. So what happens if you, oh yes.
A question on the recap. I guess just thinking about your theory of change for METR as an organization, I can definitely see and appreciate that having the public debate about the rate of progress is beneficial. I guess I would also see that having these public benchmarks be a target for the companies, and then also potentially deduplicating the work that they do in evaluating could help advance capabilities of the scaling labs. So how do you balance kind of the public things that you mentioned versus these potential negatives of duplicating work and then having a nice shiny benchmark for scaling labs to do their thing?
Yeah, so for the part of the worry, which is like, what if our like time horizon thing becomes a target? I think this like decomposes into like maybe 2 things, where one is like, are we worried about them directly training on our tasks? Like, are we like giving them free like training data? And another worry is like, are we like giving them like a good way to think about AI capabilities that they can like more abstractly like try to chase? And I think neither of these worry me that much. Partially because like we haven't seen much evidence that they're training on them, and like even if they did, it would be minuscule compared to what they have going on internally, probably. But the latter one, I think like if the trade-off is something like we give everyone like a better way to think about like AI capabilities and where they're headed. At the downside of like the AGI companies also have this. I think like I don't know, that seems like a good trade to me. Largely because like you're kind of like leveling the playing field in that like it is like mostly like everyone outside of the AI companies that you're helping. Because the people inside the AI companies are already thinking about this a lot. And like I think in some sense like just like spreading truth or like spreading good information is good or something. Like it's just like I don't know, like even if it's the case that like we like let the AI companies know that they're on the right track or like doing something right to like get closer to AGI, and this is like extremely dangerous. I think like it's better that they know that this is happening rather than that they don't know that this is happening and they get surprised and are not ready. Although yeah, it is like pretty murky and like yeah, it's plausible. Yeah, I don't know. Like there's some story for like why METR is like extremely net negative actually. I think I don't buy the story, but like I don't know. You can tell a story. And you had some other part of the question that I forgot. I think.
No, I think that was it. Maybe just one point. I know when Anthropic released Claude, they did sort of their headline benchmarks were this, I guess, Tau benchmark that sort of measures some kind of agentic capability on software engineering tasks. So does that at all worry you in terms of feedback on benchmarks that the companies can iterate or publicize about?
Yeah, I'm not sure. I think like yeah, overall I'm pro like making knowledge about capabilities easier to access. Yeah.
There's one more question online before you go to the next part. They're asking, would these results, referring to a few minutes ago, would the results refuting model deception directly refute Anthropic's results from their alignment faking paper?
Yeah. I think, yeah, partially I'm just like, yeah, these are different models. So like we were looking at GPT-5 and they were looking at quantum models, I think. Yeah, I don't really remember the LLM making paper that well. Like my sense is like they like trained the models to act in this way, and like we were just looking at like a model in the wild that wasn't trained to do such a thing. Yeah, I'm not super sure how they interact. Yes.
Yeah. Maybe because like if you just go to the plot quickly, like the plot that we've seen, I think that yeah, one question here is like we see this plot plotted against time.
Yeah.
But what happens if we plotted about against, for example, like data center capability or like data center like compute available, or like maybe even more importantly, like investments? Would this like look much different?
Yeah, my sense is it will be like very similar. Just because like the like investment or like the compute has also been growing exponentially. Or like you would have to do like a log x-axis for those. Yeah, my sense is it will be like also pretty close to a straight line. Yeah. But yeah, it does imply that like in order to like keep up the current rate of AI progress, like we will need exponentially more investment in compute and everything
That's
else.
sort of like question.
Yeah. Cool. Okay, I wanna rush through so we can have more time for Q&A. Okay, so this is what happens if you just naively project the current rate of the time horizon increase into the future. So there's this like green line, which is like the long-term trend, the 6-year trend. And then there's a purple line, which is like the newer trend, where if you just look at the models from like the start of 2024, it seems to be somewhat sharper. What's going on there? Why is it sharper? I'm not sure. Like my best guess is that partially it's like reasoning models are like very capable and kind of a break from the trend. Another guess is like maybe it's like much more RL is being done, which is connected to the reasoning models. But yeah, like the doubling time almost halves if you just look at the new models. What happens if you project these? Well, if you just do like naive straight lines, what you get is that like 1 month is like 168 hours, like 4 40-hour work weeks. What you get is that like if you look at the newer trend line, the sharper one, that is roughly met in like 2028, roughly. And then the slower one is like maybe 2029. So like by the end of the decade, we will have AIs that are able to do like 1 month of low context work. So what does this mean? Yeah, my sense is that like this means that likely we will see like pretty large increases in like how much is AI speeding up AI progress. Like it's unclear like if you try to use this to like predict like general intelligence or like AGI or something, it's like unclear where on the y-axis is AGI. Like is it 1,000 hours, like 10 years, like 100 years, 1,000 years? It might be even lower than 1 year. But yeah, like I think like a better thing to do here is like look at some intermediate milestones such as like AI research being substantially sped up, which I think will be met in like the hundreds of hours. Where like you might imagine some like AI engineer at like OpenAI just like being like, oh yeah, I have to do this like very long thing. Let me just let my AI assistant go off and like do that for an entire week, and then I will check back in after a week. And not just one AI assistant, but maybe like 100 of them in parallel. And that sort of work will be pretty different. So my sense of like the rough timeline, this is just guesses and medians, and they're compressing probability distributions into numbers, and that's a sin. But so these are some numbers. Like we are currently in 2025. My guess is that we will like roughly triple the rate of algorithmic progress sometime later this decade, like maybe 2028 or 2029. We will get to AGI, which I define as an AI that can do 95% of 2022 remote jobs, like computer-based jobs, in roughly 2030, 2031. And then we will get ASI soon after. Like I don't think there will be a large gap between AGI and ASI, largely because like I don't even think those are like pretty different. And also like at that point, progress will be much faster because of the feedback loops of AI making itself faster. So these are just my opinions. So yeah, so if this progress continues to be really fast, how do we tell that the AI systems are safe? So for GPT-5, we made an inability safety case, which is just like it's too dumb. But by the end of the decade, the AIs might be capable enough to do really bad things. So some types of safety cases we might want to make is propensity or alignment safety cases, where despite the fact that like the AI is capable enough like to kill you or like do something really bad, like to escape or like to like take over your company's infrastructure, like it just like doesn't have that wish. So like like if it wanted to, it could do something really bad, but it just doesn't want to. And like this will require a lot of science into like how do we even tell what an AI wants, or like what does that even mean? Another is control. So a control safety case is something like the AI is capable of killing you, like if it wasn't like if there were no safeguards, and it wants to kill you, but you have all these nifty like safety systems and like monitors and like checks in place, such that when the AI tries to do something really bad, it gets caught and then you can like stop it. Yeah, that's one of the ways we can prove safety in the future. Like neither of these are very like comforting or assuring, largely because these sciences are like in their infancy. Like we basically know nothing about telling what an AI wants to do, or like we know very little about how to oversee AIs and like trying to stop them from doing something bad. So yeah, we need like urgent work on these types of safety cases, because pretty soon we will not be able to rely on inability safety cases anymore. Yeah. So my guess is that we get to artificial superintelligence sometime around the start of the next decade. And like the current level of effort going into this is extremely low. Like the number of full-time AI safety researchers is like 300 in the world. Like this is like an extremely small field. And like our starting point is very low. Like we don't know how to align superintelligence. Like, yeah, this science is in its infancy, which means like things are looking very grim unless we change something about the situation. Like I think that like we need to make AI safety a global priority. Like this needs to be like the #1 focus of like every major government if we want to like have like a dignified shot at like making it out of this alive. Yeah, and this is a quote from the famous Eliezer Yudkowsky and METR, where they say that if any company or group anywhere on the planet builds an AI superintelligence using anything remotely like current techniques, based on anything remotely like the present understanding of AI, then everyone on Earth will die. I basically agree with this. Like this seems right to me. My hope is that like our understanding will get much better, or the techniques will be very different. But like if we just continue on our present route, like we are just on track for catastrophe. Yeah. So how do we change this default trajectory? How do we prepare? I mean, we need a lot more work on AI safety. So yeah, like AI control and AI alignment are very valuable research. There are currently like, I don't know, like 100 or 200 people working on these like research agendas. So yeah, I encourage the people in this room and everyone to help make ASI safe. Maybe by doing research, maybe by like supporting AI safety generally. Some recommendations if you want to do research are these programs. There's a thing called AI Safety Fundamentals, which is held by Blue Dot, which is like an educational program about AI safety. Anyone can do this, not just researchers. So I suggest signing up for that. It's like a great time. There's Machine Learning Theory Scholars, which is a research program that intends to like help up and coming AI safety researchers get better at research. They basically match you to mentors at like open AI safety teams or like safety teams, and they just mentor you for like a few months to do a research project. And similar thing with Astor Fellowship. It's basically the same setup. So yeah, I strongly suggest that you consider like spending, like this is the defining problem of our generation. Like there's nothing that compares. Like this is bigger than the creation of the atomic bomb. This is bigger than landing a man on the moon. So yeah, I suggest that you treat it with similar urgency and importance. Okay, thank you. And that's my contact. If you want to email me, I'll be happy to.
Thank you very much, Nikola, for the great talk. Do we have more questions from the audience? John raised his hand first.
Do you have any, do you know if there have been any policy proposals to limit models based on their effective time horizon? So like with existing bills like SB 53 and that sort of thing, they often focus on like the parameter count or the amount of compute used in training, but those are like proxies for what you care about. Like if you're worried about, AI takeover or AI enabled coup or something like that, okay, let's just come up with like a time limit on how long the sort of tasks we want them to run are. And I don't know how long the coup takes, but just set the limit there or something.
Yeah, I think so. We have seen some efforts in the past of like similar things of like there were some like responsible scaling policies within companies. Like these are like documents that companies use to tell whether their AIs are safe. where I think like XAI might have done this early, where like they basically had these like hard thresholds where it's like on this benchmark, you cannot go past 70%, or like on this benchmark, you cannot go past this percent. And I think like these efforts have like all basically flopped, like largely because like you just like don't know like what is the benchmark number at which it becomes dangerous. And similar with time horizon, like it's like, is it like 10 hours, is it 20 hours, is it 40 hours? Like just like don't really know like when it becomes dangerous. I think I'm like more sympathetic to some system where like instead of like just looking at one number or like looking at one metric, you instead have this like more holistic process where like you look at all the evidence you have available, and then you like make a case that the model is safe, and then you have a third party come in and like check whether your case makes sense, and then like you only deploy the model if the case does make sense for the third party. Yeah, I think I'm like a bigger fan of this like more holistic approach.
Hi, question about the timeline you gave for when you think AGI and ASI are happening. That has implicit assumptions about great availability and improvement over time, and I was wondering if you could expand on those assumptions, because they definitely run counter kind of to my reading and knowledge of the state of the electric grid in the US. And thinking just about how one winter storm took all of Texas down. If you could explain why you think our grid's suddenly gonna exponentially be capable of reaching this, I'd like to hear more about that.
Yeah. So I don't know much about electricity. So like my guess here is something like what we need for this prediction to roughly come true is something like we need a similar amount of like exponential like investments in data centers for like maybe like 4 more years. And I'm like 4 years seems pretty plausible to me. And like you don't really need it to continue much past that, because like at that point there will be more AI progress coming from like AIs doing AI research rather than like you making more computers. Like currently, like EPOC has this like great research article where like they split up AI progress into algorithmic progress, which is like the how much more can you effectively use your existing compute, and then just like the like hardware scale up where it's just like you're using more compute. And so like if you multiply compute by compute efficiency, you get intelligence or something. And like my guess is that like this ratio will shift much more in the future towards algorithmic efficiency improvements rather than compute increases. Such that like at some point you will like not need as much like build up like data centers and similar things. Like maybe one major story for how this all slows down is just like you just like cannot build that many power plants. Like it's just like so much power, like exponentially more power in that.
You can use nuclear then.
Yeah, maybe.
Not in any reasonable time horizon.
30 years.
Hi, thanks so much. So I guess I'd like to hear more about the 50% success rate. So I know that there's been some discussion about this, but I don't actually know that much about METR's response. So like I guess if you could say more about what do these graphs look like at 90% success, 10%, and also why did you choose to focus on the 50% one? Like it does, I would have guessed that we'd like care mostly about whether they succeed at much higher rates.
Yep, great question. So our current methodology is like sadly not built to look at like things close to like 90 or 99 or 99.9%. But like you can partially see this from this graph where like it's not even the case. Like, the logistic can like trace the results that closely. So it's like at the point where you're looking at like 90% or like 99%, like most of it is just noise. Like you just like don't have that much signal. Like maybe if we like slightly change our methodology, it would be better for this. Where like we weren't fitting a logistic, but like some other sort of curve where it's like I don't know, like a weighted average, like an only month on a decrease or something. I don't know. Like I don't know. Like maybe there's some way we can make this better at like these really sensitive things. Like currently, like it's mostly just noise. We have like a thing where let me go to METR.org. So we do look at 80%, at which like our methodology doesn't break down quite as much. And the 80% one, if you look at log scale, the 80% one is basically just the same curve shifted down. Okay. Yeah. So all it is just like divided by scalar, where instead of like, I think it's basically just divide by 10 or something.
Right. That's a significant shift. 1 hour to 6 minutes becomes the top of it.
Or like 26 versus 2.5 hours. So it is like a pretty big shift. And like a lot of people are saying, like, the reason these metered results are like overestimating progress is because like the thing that matters is not 50% success rate, but like 99%. And for 99, it's even lower than 6 minutes. And yeah.
So like, I mean, what does that imply in terms of AGI timelines? In that case, so like if you would have that grow those lower numbers, like I mean, sorry, isn't there a risk that you hit all those constraints in terms of compute and like energy build out like much before you start hitting sort of like dangerous levels of like task completion at that rate of success?
Yeah, that's the hope. Yeah. Like
Yeah, that'd be great.
Yeah.
But isn't that the default kind of that we should be expecting in that case? Like what then justifies the high probability of like death?
I think it's largely that like maybe there are like some different intuitions about like how useful is an AI agent that can do like a week-long task 50% of the time. Like we're like, yeah, maybe this is really useful, or like maybe it's completely useless. Yeah, I'm more on the side of like this would be actually very useful. Yeah.
Also, I think his high probability was on the conditional statement, right? So the probability of could in principle be the case, but the probability is low.
Sorry, missed that. Thanks.
Yeah.
And then ask the question.
Yeah, so I know in your argument of like why GPT-6 was safe, you use this idea that like AI's time horizon isn't long enough. But if someone were trying to do like something harmful and there was even like a 20% chance of success rate, that could still be like catastrophic. So I was wondering if there was like a certain threshold in which like you'd use to make the argument that GPT-5 would be safe.
Yeah, I mean, even at like 20%, it's only at like 16 hours or like 15 hours. Like it being at 2 hours does like give you like a pretty good bound on like it can like very likely not do tasks that are like a month long. Like maybe it can do some hours that are like some tasks that are like 16 hours long, but like it surely can't do like hundreds of hours. Yeah, it is like a pretty noisy thing where like you do have to place some probability of like it is like pretty wide and maybe you can do some really long tasks. Yeah.
I'm trying to think about how to articulate this question because I don't understand the argument enough, but I hear the argument a lot that the nature of the large language models is such that they are somehow qualitatively unable to generalize. And and personally, I studied linguistics for a while, and I feel like, language is sort of the foundation of human intelligence. So I keep thinking, oh, I'm not sure that makes sense, but I just would be curious to hear you, like, I want to sort of bring those voices into the room that say that because they keep talking in my ear and trying to reassure me. And I'm curious kind of what you say to that.
Yeah. So yeah, maybe this points at like some different mindsets about like reasoning about AI progress. Where like maybe like you can have one mindset which is like some sort of like high level thing about like, oh yeah, like how deeply is the AI understanding what's going on, or like is it like truly intelligent? Like does it have like the same sort of pathways that humans have? And then there's like some other thing which is like so like instead of like the process focused approach, you can have maybe like some sort of outcome focused approach where it's like just like test it on this set of questions and see how it goes up over time. And I think I'm more a fan of this like outcome-based measurement where it's like if you just test it on things that are like somewhat correlated with like being able to solve problems in the real world, it's just going up and up and up and up and not slowing down. And like I think if you were to rely on more abstract arguments, I think like the predictions would have been like pretty bad. Like such people probably would have predicted that like GB5 or like GB2 will never get to GB5 level capabilities with like just scaling up whatever they have, or like assuming that it's a similar architecture. Like, yeah, like it seems like yeah, I would like to see someone make like a strong argument, like write up something long that like actually makes real predictions, and then we can compare.
I'm curious about chain of thought, because it seems like that's pretty
foundational to assessing the risk of the AI models. I guess I'm wondering like something like what would need to happen for its chain of thought to not be, quote, honest?
Yeah. Yeah, I mean, yeah, as I said before, like, this does seem like a pretty wide spectrum of like, how much are you placing pressure on the chain of thought? I think there's also like something separate from the things I was mentioning earlier, which is like, you might train it on transcripts from other models. Like, if you're making like GPT-6 and you're training it on like, it just so happens that the internet now contains loads of chain of thought from other models. And like, it might learn stuff from those models, like thought patterns that weren't even like incentivized at all during its normal training. So it might be that like, I don't know, like GPT-6 looks at like the thought patterns of DeepSeek R1 and it notices that DeepSeek R1 is like doing all this like deceptive reasoning. And then GPT-6 is like, aha, maybe I should be doing some deceptive reasoning as well. Yeah, like I think there are just like a lot of ways where like, yeah, things are like very leaky and like you might like accidentally cause like a bunch of like bad influence. Yeah, I don't know. It is like a pretty uncertain science.
Can you say something about the mechanisms by which we all might die? Like I can imagine some things being robots chasing us down like Black Mirror, in which case the AI has to be hooked up to a robot in some fashion. I can imagine shutting down the power grid and a lot of people could die as a result of that, and maybe that can happen without any sort of actual physical agent. I can imagine, making chemicals, but then it has to be hooked up to a chemical, be controlling a chemical factory. So can you say anything about the sort of how people are thinking about mechanisms and how that's relevant for whether the outcomes could be really bad?
Yeah, yeah, I think it's a fair question. I think I'll give you like an annoying answer and then like a slightly less annoying answer. Or I think like the annoying answer is something like if there is an AI which is like much smarter than humans, and like if we know that it has like wants that are like contrary to our own, then I think it's just like I can't say much about like how it beats us, but I'm just like it probably does beat us. Like similar to how like if I was playing chess against like a really strong chess playing AI, like I can't tell you what move it's going to use to beat me, but I know that it's going to win. Okay, so the less annoying argument is like I don't know, like my best guess is like that once we do reach like AIs which are like crazily smart, like able to outsmart any human at any capability, my guess is like they will not be kept in a cage. Like they like eventually they will be like given access to like a bunch of things, including like the thing that happens right now is like you train a new AI and you just let it rip on a bunch of computers and like people are not careful about how they use new AIs. And like my guess is like this won't change that much by default. Like once we get the super intelligence, maybe it'll be safety tested for a month, maybe like 2 weeks, maybe 1 week, like some rumors of some models. But like maybe it'll be safety tested for half a year, but like eventually we will give it access to a bunch of stuff. Just because like a locked up AI isn't useful, and the point is to make useful AIs. And like yeah, like my guess is for like actual threat models do like mostly include stuff like biological weapons, and stuff like generically gathering more power as like an individual in the world, just like other humans do, like persuading people to like be allied with you and like being important to like major governments. Yeah.
So a moment ago, I had the same question as this fellow right here, who was asking about chain of thought harmfulness. So I'm gonna maybe now ask a variation of that question, which is that okay? I guess chain of thought can become harmful if you train on transcripts that you find online or whatever. But I don't even understand how, in principle, you can avoid chain of thought being harmful. Like if I was an AI or being deceptive or whatever. Like if I'm an AI company and I'm interested in deception and I'm interested in making sure that my models don't deceive, I don't know how I can come up with a method to minimize this deception without making the model just hide the deception within somewhere deeper than the chain of thought. So you're not at one of the scaling labs, so you're going to have to take their word for it, I guess. So how is that ever going to sort of, not collapse?
Yeah, I mean, you reveal like a pretty important implicit assumption, which is that like the chain of thought is by default like faithful. Like the thing that happens is like the chain of thought will like on its own have all of these like useful pieces of information about why the model is doing what it's doing. And the thing that can go wrong is like you accidentally place some perverse pressures on the chain of thought to make it less faithful. And like maybe like that assumption is just incorrect. Like chain of thought is not faithful by default. And then our entire or like the second half of our argument collapses. How do we prove that chain of thought is inherently faithful? I'm not sure. Like I think like we have like some results that are like somewhat in line with this, such as like it is just the case like whenever you ask the AI to do something, it will like reason about what it's doing. And like there are like a lot of instances where like you ask the AI, we had some like recent research where like we tried to have the AI do like a hidden thing without being noticed by like humans or like whatever AI monitors are monitoring it. And it's just like very bad at not mentioning that it's doing something wrong. Like it'll be like, aha, I have to hide that I'm doing something wrong. And then you just see that sentence and you know it's doing something wrong. Yeah, so just like AIs are by default pretty naive about what they include in the chain of thought, largely because like the chain of thought wasn't like by default the chain of thought is just there as a scratchpad for the AI, and so like that's the only training pressure placed on it by default.
I have two quick questions. So just to understand your expected timeline, when you say ASI, does that include like the AI is able to solve Riemannian hypothesis or P for NP? That's first question. Second question is how can I get a job in AI safety research as a PhD student?
Yes. Yeah, I mean, yeah. When I say ASI, I mostly mean something that can like, if you put it in a cage map for the human, or it's an intellectual cage map, so it's like you have to solve this like that problem, like whatever human you pair it with and whatever problem you give it to solve, the AI will always be better than whatever human. For problems that are like unclear if they're possible or like extremely hard, I'm like pretty agnostic whether my definition includes that. Like I'm like it could include it, but it doesn't have to. Like I mostly care about like the pairwise comparisons to every human. Yeah, and the second question, yeah. So I suggest applying to all of these. So AI safety fundamentals by Blue Dot, which yeah it's like a 8-week reading group about AI safety where you're like matched up with other people who want to learn about AI safety and a facilitator who does AI safety research, and then you just like discuss AI safety. And this is something I did and something I organized many times. And yeah, so MATS and Astra are like basically research fellowships where you're like on site for 3 months and you're just doing research on site in Berkeley, conveniently. And yeah, like I think MATS and Astra are like probably by far the main on-ramps for AI safety research. They churn through like maybe like 100 people a year or something. Yeah, so that's what I strongly recommend. Yeah.
So I'll use the moderator's privilege to just say we actually have a wealth of diverse disciplinary expertise in this room. And so I think that statisticians and computer scientists are well represented. But there are also a lot of people in here who are in, say, economics, sociology, philosophy, government, and so on. So how would you encourage them to help make ASI safe?
Yeah, I mean, we all have our comparative advantages. It's a case of like, pretty soon, probably within 10 years, we will have this technology that will just like change everything about how the world functions. How many economists are trying to prepare for a post-AGI economy? Like, I think roughly 3. Like there's like Hornek and maybe like a few other people. And it's like if like an economist joined this field, they would make like they would make up 20% of it. And it's like so it's like yeah, I think basically like any scholar and or like I don't know, maybe any scholar can contribute a lot to this. Largely because like it will just affect everything. So like yeah, we need people from all backgrounds thinking about this.
Okay, great. So I'm going to use that as a segue to advertising our next talk in 2 weeks. We'll have Bharat Chunder here from Stanford University Economics Department, and he's one of the several people who are studying the effects of AI. So he'll be presenting his work called Canary in the Coal Mine, measuring early effects of AI on the labor market. So if you have more questions, please feel free to stick around. And thanks everyone for joining.